Hello and welcome, everyone. I know people are still joining us, but as we get started today, today's topic will be biomass and anaerobic digestion. So what's that got to do with where we've been and where we're going? As we get started today, I did want to talk about some of the polls that we conducted last month to let you know what you all said. So once again, I'm Dan Anderson, and I'll be doing most of the talking today. Uh, I work at Iowa State University in the Agricultural and Biosystems Engineering Department in the area of manure management, and I'm excited to be sharing some of the things we've been thinking about in terms of anaerobic digestion, how to make it scale to some different farms, and the role biomass may play in that. So when we think about what we asked last time, our first question was about policy awareness. As you'll recall, last time we talked a fair amount about some of the policies helping support anaerobic digestion and the carbon credit. We had a lot of great familiarity. 3/4 of the people said yes. 25% said that they didn't know some of those. And certainly from my perspective, they're always changing. So I think it's important to stay up to date on them. One of the things I wanted to highlight is that we had a poll question of, are you interested in hearing more case studies of anaerobic digestion? So as you might recall last time, and we'll do it again this time, we're asking some companies to sign up on projects that you've done, or if there's something about anaerobic digestion that you'd like to share with all of those on the call. We are excited to help facilitate that. We will be taking a short hiatus from doing these, so this will be the last one for 2024, but we plan to start again in March of 2025 with these anaerobic digestion webinars, and hopefully alternating between a company and then hopefully something from a university that we can share relative to the digester world. One of the things we asked last time, we were really interested in what does it take to be a project? What are people out there concerned about or looking for? So we asked what are some of the factors that are getting you excited about investing in anaerobic digestion? The number one was return on investment, right? Almost 2/3 of the people said that was important to them, but we did see a smattering of other things, especially environmental impact and policy incentives were big factors for why they're thinking about investing. And then with that, we asked, what are some of the concerns you have around the financial aspects of anaerobic digestion? And these answers were a little bit more varied, right? They were split evenly among all the categories, but certainly upfront costs were a concern. We do know that digesters can get a little expensive. So I think trying to understand some of the models that people might be looking for to how to make a system feasible for lots of different farms rather than just the largest farms is important. Thinking about maybe some of the uncertain return on investment relative to some of those policy incentives and how they might change in the future. And then just some of the unknown. What are the maintenance costs or how this is going to impact me over the long term? And then finally, in that realm, one of the things we wanted to know about was curiosity about community digestion. And certainly that's a way to help projects potentially scale to reach more farm sizes to be more impactful. And almost half the people said yes, and almost everyone else was in that maybe category where they'd think about it. And certainly that's a topic that hopefully we can have more discussion on in the future in terms of what that might mean for biosecurity protocols. But if we want to try and get digesters to scale maybe down to average size swine farms in Iowa, I think that might have to be an option that we have to look at or pursue. So with that said, today we're going to focus on biomass digestion. Let's minimize that. See if we can get our next one open. Slideshow from beginning. So I had a wonderful student that I shared with Raj Raman named Gabrielle Myers, and while she's went on to do some bigger and better things, one of the things she did here was a cost assessment of centralizing a swine manure and corn stover co-digestion system. So looking at how this could work. As you can see, we've put up a poll question for you. So if you can answer those as we go, we'd greatly appreciate it. We do like to try and share what you all said later on to hopefully get some perspectives as where people are at with the biogas industry perspectives and what might be concerning or important to them. So if you have a chance, please do answer those poll questions and we'll try and update what people are saying by the end. So with that said, I'm going to try and walk through what Gabby did to try and say, what are some ways that we can maybe make these systems work cost-wise on Iowa swine farms? So we all are interested, or at least excited or interested in the biogas industry in Iowa. And when you look at the state of Iowa, we're really rich in a few things. We have a lot of livestock facilities, and as Luke talked about last time, currently roughly 78% of all the dairy cattle in Iowa that exist probably exist on a farm that digesters look to be feasible or at least close to cost feasible. On the other hand, when he looked at those swine farm scenarios, very few of our pigs were on facilities that it looked like that facility alone could support a digester. So what Gabby's work was really focusing on is what are ways to think about scaling? How can we make this a technology that will fit more farms? We know that right now there's great incentives or markets for some of that renewable energy. I know that many of the livestock industries have put out pledges towards carbon neutrality. The dairy industry really has that 2050 push for the carbon neutral cow, and many of our swine organizations are moving similarly. We've seen pledges from processors, Nestle, Dannon, Smithfield, JBS, right? So we've seen a lot of interest in this, but what's a roadmap of how to get there? And given the credits that we have currently, is there a way to make these work on the types of farms that we tend to see in Iowa? And when we think about what Gabby did, and she focused on swine manure, mostly because swine seemed to be a larger issue in terms of how to make them fit than what we had seen with dairy cattle. And then we looked at what's a material that we can add. Certainly there's lots of options, and we asked you maybe what are some of the things that you might be thinking about, things like food processing waste, or scaling to have community-based digesters, or using biomass. And I think all those make some sense. There has been a lot of work on food processing waste in the past, or bioindustry processing waste in the past. So we didn't focus as much on that, but wanted to focus on something that's out in the countryside and maybe could impact farmers. And because we grow so much corn in Iowa, it seemed like corn stover was a natural fit, at least as a first step at looking at. It's not the only biomass. Certainly we could think about things like cover crops, or other grasses or forage crops that we could harvest and dedicated feed to a digester. But at least for getting started, we thought corn stover made a lot of sense. So that's what she looked at. And she's going to demonstrate for us 4 different scenarios. And scenario 1 is really that pig farm business as usual. So the average pig farm in Iowa has 4,800 head of pigs living in a deep pit facility. And what we said we could do as a first case scenario for that farm is take all of its manure. We're going to run that through a heated mixed digester. We're going to add enough corn stover to bring that mixture up to 12% solids. So when you look at what our typical deep pit manure concentrations are for solids to start with, we're hanging around somewhere in that 7 to 8% solids range. And we said, well, for the digester types that we're looking at, we can probably operate them at close to 12% solids before we'd have plugging issues. Certainly that isn't a hard or fast rule, but it gives us at least a range to start with. So we're going to take enough corn stover to get to that level. And then since that's all the digester can take in terms of solids loading, we have to stop there. And then we're upgrading to renewable natural gas that's injected into a pipeline. And for ease of modeling, we said that pipeline is going to be located basically right at the farm to help keep costs down. A scenario we compared that to was what would happen if we basically doubled the volume of the digester. And we'd have the same amount of manure. We'd add that corn stover to it to bring it up to 12% solids. As that material came out of the digester, it would be solid liquid separated. The solids would go to a solid manure storage. The liquid stream would be split into 2 halves. Half of that liquid stream would be recycled back into the digester to facilitate more loading of corn stover into the digester, essentially trying to make the plant bigger. The other half of that liquid effluent would go off to liquid storage, where it would eventually be land applied. So really an idea to trying to still be that single farm, everything under your control, but just getting to a bigger capacity by taking more of that biomass material. Scenario 3 was really looking at what if we had just 5 farms working together, taking that pig manure and sharing an injection point that was 2.5 miles away. So we have a great question. What is the nutrient content or the NPK of corn stover? And it's actually relatively low. It's something like 10, 10, 10 per ton of stover. So relatively low. And that's sort of the advantage of it. We're taking something that's relatively nutrient rich in terms of pig manure and mixing in something that's a relatively low nutrient density in terms of corn stover. So when we think about digestion of pig manure, oftentimes we have lots of nitrogen relative to carbon, and we worry about things like ammonia toxicity to the bacterial community there. And we really want to take relatively carbon rich materials to add to that. So corn stover fits that bill. It's got a lot of carbon, relatively low amounts of nutrients. You can mix other things in there, but for instance, if you had pig manure and we're adding in a bioprocessing facility wastewater, that might also have high ammonia concentrations, high nitrogen concentrations, and we might not be making much progress on getting a higher C to N ratio, but instead staying closer to where we were at. If you think about other manure types, dairy manure, for instance, it tends to have much lower nitrogen content than swine manure. And that maybe makes it more amenable to taking a wider variety. But in this case, we really were wanting something that had lower nitrogen and phosphorus concentrations to try and mix with that manure to get our microbial community probably a little bit more stable and a little bit more robust. So in this case, they were just sharing that gas injection point. And then the last example was, what if we were moving manure to a single site so that we can really scale the digesters to be bigger, right? So scenario 3 and 4, we should make the same amount of methane, right? All the cases were the same. It's just a question of where we're really doing that digestion. So on scenarios 3 and 4, they're really scaled so that each individual farm was from scenario 2, right? So taking as much corn stover as we thought they really could. You could think about recycling that effluent more and more times, but as Ed pointed out with this question of how much N and P are in corn stover, every time you recycle that material, that liquid back through the digester, you're going to build up nitrogen and phosphorus in that liquid effluent just a little bit. So at some point you'd have more concern about how you could stably operate that. We felt pretty confident with that one time recycled. As you get more than that, it really becomes much more dependent, and you need to do more testing to ensure that it'll be a safe mix to keep operating as you move forward. So just some assumptions about the values we were at, a formula for how we calculated digester capital cost. It comes from the literature. It was developed for cattle digesters, and we amended it to work here. You can see what we assigned for a RIN value. That RIN value is relatively low now to what we're averaging, right? But it was the price when she did this work for us. The LCFS price here is probably a little high compared to where it ended up. And then that pipeline cost is really dependent on where you are located relative to a pipeline and your ability to negotiate to get a pipeline deal. But we said as a base case, hopefully we can get that done for roughly $1 million. So just showing some of those assumptions and how they work. The capital cost associated with that pipeline in terms of how much you're getting out of it is dependent on how much gas you're making, right? So bigger plants definitely come out ahead in terms of taking advantage of that full pipeline ability. And then comparing to some city gate natural gas prices and where natural gas prices have fluctuated over time, you can see that there's a fair amount of variation there, but we were working with that average value. So there might be times where it's more valuable or less valuable, but sort of our assumption was that we had to make it meet or make it work here at roughly on average. Jumping right to the results, and this shouldn't come as a big surprise to start with. So the red bar here is if you have no carbon credit markets, if you couldn't play and collect D3 RINs, or if you couldn't collect LCFS money, our price for natural gas ended up being quite high. We weren't competitive, and that was assuming a 20-year life for our digester, essentially, right? So trying to make the project pay back over 20 years. When you add in some of those credits, we couldn't make either of our individual farm scenarios competitive with natural gas prices, but they were substantially improved compared to where we were sitting. Even when we did that sharing a natural gas injection point, it didn't help us out enough based on how we set that situation up. But if we were able to move all our manure to a single site, really take advantage of that capital cost reduction from having a large digester all on a single site, we were able to bring this price down. A couple other things I should mention. All our assumptions here are that manure would be moving back to the original farm. The corn stover separated solid biomasses would all be moving back to the original farm, and we accounted for that in our pricing in our model. So essentially, we weren't changing how nutrients were flowing. We brought them all to a single point and then had to pay to redistribute it. So that was sort of where we're at. But I think this was good news, and one of the reasons that we're interested in what's the potential for adding biomass crops to digesters. With swine manure, with deep pit facilities, it looks to be a hard road to build a digester for the types of facilities we have right now. We really have to be thinking towards that community digester concept or model. And what we saw was even with 5 swine farms working together, that still wasn't really enough manure to justify that digester. So your projects either have to get really big, moving manure from lots of farms, 10, 15 farms to a single digester site to hit that economy of scale, or we have to be thinking about what else can we be adding to these digesters to maybe make more gas with the material that we're working with. And at least in our modeling there, if the swine farms were within 2.5 miles, and they were harvesting corn stover reasonably aggressively on the land that they were probably using to manage their manure, we were in good shape. So in this case, they were harvesting corn stover from about 70% of the acres they were putting manure on. So that is a relatively aggressive harvest, but certainly they would have acres that they weren't harvesting that corn stover from. We were assuming they were taking roughly half the corn stover off every acre that they were harvesting. So making sure they were leaving there for some there for ground cover and environmental sort of attributes for erosion control. But the good news really was that we did find a way to get a system that started to look cost competitive or had the potential to pay back. Certainly that's not the only model or only way to do that. But given the conditions that we have today, it was a sign that this could be done or is at least an option of how to find a way to make these facilities cost feasible. So again, without those credits, we weren't competitive with natural gas. Our modeling suggested that centralized upgrading and injection alone wasn't really advantageous. Certainly that depends a little bit on your exact scenario and how you put this together. But that is what we were finding. And then our final one is if we completely centralized, we did get there. Ed asked another great question. If you change all the scenarios to combined heat and power, is the dollar better or worse than with no pipeline? And this is a complicated answer. And right now it would be worse just because with combined heat and power, we aren't able to really capitalize on those D3 RINs because there's no electric RIN. And given that we're in Iowa and if we're making electricity, we're not able to capitalize on those LCFS credits. So right now, it's hard to find that economic value there, and you'd still be better off to try and chase after this scenario 4 where you're completely centralized. If we want to try and make them work on smaller scales, and I'd tend to agree with what Ed's question here was, if another way to make them work is to move away from this pipeline model and find ways to incentivize making electricity. We need that heat anyway, and there's some natural opportunities there. So we didn't directly compare a single farm, what would happen if it was combined heat and power making electricity towards our infrastructure here. I think if we look at some of the modeling results that we've seen in the past, some of those electricity systems, at least on some of the farm size scales when they're not taking biomass, made a lot of sense. So I think there's some opportunities there. It's great, Ed, and we will take this model and modify maybe to one that we pulled data from, that Fallhaber one, to see what would happen if we were just making electricity and giving up some of these credits. Because you're right, the electricity market, you get to reduce some of those capital costs, especially with the pipeline injection or the level of gas cleaning system that you need to meet the requirements. So that's a great point. The other thing we wanted to point out is that just because we on average were able to make that farm make some money, that wasn't always the case, right? So it was a break-even project over time. But if you looked at the RIN market fluctuation and the LCFS fluctuation, where we're falling is this making money. If you're above that line, so these periods in 2020 or 2016 here, that would have been periods where the project wasn't making money. So building right next to that break-even point sort of adds some difficulty or some struggles to consistently making money. Again, it was never competitive without credits. Certainly that's something that we need to be paying attention to. The credit market at least was really important for making these projects cash flow, but we did increase gas production and make better utilization of our assets, that digester, making sure that it was getting as high of solids load as cleaning system and our gas injection system. There were periods where we could make a single farm cost competitive. It just didn't last very long during that 2022 period. So I don't want to say there's no hope for that, but it was a small time period where the results actually, the credit market got good enough where those could be cost competitive. One of the things that needs some more work on, and Luke, who talked last time, is trying to do some improved work, is really understanding when moving manure around or when moving gas in different forms might make some sense. Gabby tried to do some analysis of what are some prices that are out there. S4 was sort of her line for if you're moving just the manure around. And then the other ones are sort of variations on what people say pipelines might cost. And based on that, if you were an optimist on how to bring pipeline costs down for moving that gas around, it can become the most cost competitive option. But there's quite a range out there, and I think it remains to be seen where the industry sort of ends up for ability to manage some of those prices and where we'll go from here. But I think there's at least hope that if we can find ways to bring those biogas transport costs down to get to the centralized injection points, there's ways to make those systems cash flow. It's just a little bit more of an uphill battle in figuring out what those true market costs are going to be as we think about Iowa and other states where pipelines would have to be developed. So our first thing take home from that is at a typical deep pit swine farm, given maybe some of the infrastructure challenges we have of having to build new manure storage, since we won't be able to use that deep pit for our storage anymore, it has to be a manure extraction pit that goes into the digester. Just the scale of that farm not having maybe as much manure as we'd want for a typical digester project, it was hard to make that farm cost competitive. As we started adding more material, moving towards that community digester model, there were some options that opened up to us. Based on where we were at for current estimated market prices, we thought that transporting manure to a central anaerobic digester facility was currently more economically viable. But given the variation of what people have reported for pipeline projects, certainly there's an opportunity that moving gas could be better, especially if we can find a way to bring maybe that midpoint down to some of the lower, more optimistic estimates that are out there. So again, Gabby was a great student. She did all that work on that for us and has moved on to better things. But I think it was really fundamental, great modeling to sort of say, this is what projects could look like or what we might have to do to make some of these projects emerge. And then the last thing we wanted to talk about today was some of the integrating digesters on a farm and some of the practical considerations for what would happen if we were trying to take some of these other materials for digesters. And I think that's where a lot of the questions that we've had maybe throughout this series have been around is what does this really look like, or how does this play on a specific farm? What questions should farms be asking? What questions should project developers be asking to make sure they can work together? So we'll try and address some of those here. So this is the diagram that Luke showed last time, thinking about how we'd have to manage a farm or how a farm might change. If you think about where we've started, a conventional farm is really just a barn with some sort of manure storage. And what Luke showed was that dairy farms where we have that barn, get the manure out of the barn towards that storage, tended to be more cost competitive than maybe some of the swine farms where we had deep pit storage, because they can still use their manure storage as a manure storage rather than having to fundamentally think about how to modify their system. And then there was some other things we could do along the way, right? He looked at what's the potential for just putting a cover on that manure storage, something that we've seen happen quite a bit in maybe some of the warmer regions of the US, specifically over in California, North Carolina, or maybe down in Missouri, and upgrading that gas. As you move maybe towards the north and where we've seen digesters before, New York, Wisconsin, and maybe into Iowa on a lot of our cattle farms, that just hasn't been as much of an option given the cooler climatic conditions and the lower amount of gas you're going to get from your covered storage because of the lower temperatures that they experience. So that was really looking at that anaerobic digestion facility and then taking gas from either there and a potentially covered storage or an uncovered storage. If we start taking other things and adding biomass to that, it does limit our options somewhat. Most biomass, especially from the European experience, has been put into some sort of heated and mixed digester. We really haven't been putting it into just a covered manure storage and letting it decompose. That leads to a lot of solids handling issues. The other thing is, if we're going to run that material through a digester and then think about a covered storage after that, if it's a material like corn stover, we probably need to run solid separation before we put it into our covered storage, just because it's going to be hard to get those solids out. So all these steps add some complexity to the systems. They make them a little bit harder to manage, and maybe they change how we've thought about or dealt with some of our manure before. For example, if we had a deep pit swine barn, that manure storage is directly under the barn. We probably were just letting it be stored there and then land applying once or twice a year. In this case, right, that's going to be a lot more involvement with our manure storage system. We're going to be taking manure out all the time. It has to be leaving that facility, leaving that barn, going into some other storage. And if we start mixing things into it, as Ed pointed out, that nutrient content of the corn stover is going to be a fair amount lower. So we've all of a sudden started changing what's left for that farm to use or land apply. And they may or may not want to manage something that's coming out at 10, 12% solids. Certainly we'll have some decomposition during that digestion. And if we're lucky, we'll get it back to 6 or 8%, but the material is vastly different than it has been. It'll be more fibrous. It might look more like a dairy manure, and that changes some of the pumping and handling characteristics. And because of that, they still might want us to solid separate so that the equipment they've had is feasible or usable. As we think about what maybe manure management should do, what digesters should do, we really want things like reduction in odor, maximizing the fertilizer power of our manure, right? So we know that digesting can be helpful. We're going to take some of that organic nitrogen, turn it into an available form, that ammonical nitrogen, and that matters more on cattle manures than it matters on swine manure. If we have covers on our storage, it'll increase some of that nitrogen retention, and it's great at reducing greenhouse gas emissions. I think those are things that are pretty sound and solid in the literature. If we think about what do we want this digester to be doing if we start taking other residues, this is where it gets to be more of a conversation and how we should be designing systems moving forward. I think you'll often see that we want to improve circularity, and that might mean trying to make sure that we're moving nutrients around in our ecosystems, our fields appropriately, but still taking advantage of them, right? So trying to still make sure we're maximizing the soil health benefits and not stealing from them if we're going to be harvesting cover crops, for example. Certainly, we're doing this to make energy. That's what the project has to be fundamentally based around. I think we all probably have goals of increasing farm productivity. I know when I look at what we grow in Iowa, right, we grow a lot of corn, and if we had a value added product for corn stover, it makes that acre feel more productive because we're taking advantage of multiple pieces of it, especially if we can do so in a way that makes sure that we're not negatively impacting soil health or soil carbon. And I think maybe the area that is most exciting or a biggest opportunity, and potentially one that we don't know as much about, is what does it do to encourage cropping innovations? For example, the ability to harvest cover crop because we have a use for it. At many of our dairy farms, we've seen them move towards a cover crop silage, corn silage rotations. And it turns out that that can be a successful rotation. We've seen many farms do it well, but if you don't have a ruminant to use that cover crop silage, you end up growing cover crops only for the soil health benefits, and that can sometimes be hard to justify from a cash flow situation. So I think there's potential like that. Could we be harvesting that cover crop for a digester, and does it encourage us to get some of that adoption? And that remains to be seen, and it comes down to what are the incentives and how are these systems going to be encouraged or incentivized? So I think as we look towards the future of what biomass might be and what we might want to get out of it, it's important that these conversations be occurring at all levels, both at the farm level and at the administrative level, especially around what benefits we want to see on the landscape and what we want to be trying to encourage. They do add a lot more than what we've been used to, right? And I think one of the big reasons that we've seen manure digesters come first is partly due to the carbon credit market and the offsets that they get, but it's also some of these things are handled for us, right? So if we go to a big dairy farm and say the storage is manure, well, the dairy farm was already doing that feedstock storage for us. It's being generated at the manure, and we didn't have to make a substantial investment in that. Manure is already pre-treated as it goes through the animal's stomach, right? It comes out ready to be digested. And if we start harvesting corn stover or cover crop biomass, that isn't true. We have to go get it. So it does add some more complexity, and that's in addition to the tanks and reactors and biogas collection and storage and digestate handling systems that we've used. And unfortunately, I think maybe if we start adding some of these materials, digestate handling gets to be more complicated. We have to do some separation steps and think about how we're going to manage different streams accordingly. And that's something that many of our farms haven't had to do. They get to invest in one piece of application equipment and use it accordingly. But in some cases, we might have to be splitting them. Ed asked a great question. Are there many integrated farms in Iowa, swine and poultry, or other things where we could be digesting? There are some integrated farms, but they are not the majority. They're definitely a minority of farms. Poultry especially is often separate from the other ones. We might see some people with pigs and cattle, for instance. There are a few people with turkey farms that also own swine farms, so that you can see this, but it's very much a fringe case. Now, with that said, they are located in similar regions, so there are opportunities to take materials from multiple different farms and sort of integrate them together. So that is something that we could potentially see. But it does take working across different farmers, different producers, and potentially different integrators who control parts of that system to make those work together. But the general Iowa farm, most farms are still tied to a land base where they're utilizing that manure as a fertilizer product for their crops. So there is a demand for it. When you look at where Iowa sits today, about 30% of our nitrogen, phosphorus, and potassium needs come from livestock manures. So in much of the state, we do see this idea that farms want to use their manure. They're finding ways to utilize it meaningfully. And that means if we do have community digester systems, oftentimes they want those nutrients back. And I don't want to say that's universally true, but it's oftentimes true, especially if you have been valuing your swine manure as a nitrogen management tool for helping support your crop production. With some of our cattle facilities, it might be possible that they want that nitrogen back, especially in a more available form, like digesters might present, but the phosphorus potentially has less value. That soil phosphorus test might be high from years of manure use. And if we had a treatment or separation system where we could export the phosphorus from the farm, or the digester could have that and sell it, there's some opportunities there. Jane asked a great question about composting, and we didn't talk about that at any of the previous sessions. It is something that we hope to discuss in the future. I had a student named Jin who did some work on composting some of these materials coming out and what sort of scales we can have to get to before composting starts to make sense just from the investments that you make. And we will work on sharing some of that data in the future. But we're going to talk about it here in a little bit to get a flavor for it about why composting might be important, especially in terms of CI scoring and what people might have to do. So just thinking about how this might look compared to what we've been doing, we do need infrastructure to get this done, right? We're going to have to think about silage or biomass storage, whatever form that might be. If it's cover crops, it'll probably be silage, not 100% guaranteed, but probably silage. If it's corn stover, it might be more towards that dried baled storage. And if we're modifying from deep pit storages, we might have to be building outdoor lagoons and thinking about solid separation. And as Jane mentioned, in some cases that solid material might need to be composted when we come out. Just stockpiling some of that material alone may not be sufficient to offset some of the nitrous oxide emission potential it generates, and composting might be a technology to help with some of that, especially at the scales we get to. I wanted to show a few pictures of what it is out there in terms of what the world is doing to try and get manure out of barns. Certainly the top picture here is just a standard dairy farm in Iowa. So the dairy cows are under that loafing barn. Manure is pushed out into a manure storage. And right now that manure storage is relatively full, waiting for land application in the picture. But that's an easy access point to get manure, right? The manure comes out of the barn every day. Multiple times per day, and it's an easy access point for manure. The bottom picture shows a deep pit under construction. That manure falls as it's excreted, falls down into the pit. It's stored there in terms of land application. So in that case, we don't have this easy access point for manure, and we have to think about ways to get manure out. As you look around the US and the world, there are systems where we have used shallow pits, and on some of our beef farms that have integrated digesters in Iowa, they would have that more shallow pit scrape system. So you can see a scraper there, and that would push the manure out of the barn either once a day or multiple times a day, depending on how close it was to the digester and how to get it picked up. We have seen other companies look at, are there ways to try and do a better job of flushing material out of a more traditional type of deep pit barn? So this is a mass agitation system. Essentially, they're pulling liquid out, recycling it back, and trying to flush or cause a push of the manure from one end of the barn to the other, where they can suck it out again. I think it remains to be seen how some of these systems would integrate in a barn. And you might be saying, why does this matter? Why is it important? If you think about that deep pit barn, generally we're done pumping when there's somewhere around 8 inches to 14 inches of manure left in that barn. We can never get it emptied out. So the longer that manure sits in the barn without us being able to get it emptied out, we're going to add maybe an inch of manure to it a week. We'll have 14 inches there, and we start taking old manure out of the barn. If that manure has been sitting in the barn, it is releasing some methane while it's sitting there. Our decomposition or our gas production potential as we take it to the digester after that just isn't as good as it was. We've lost some potential and we haven't saved as many greenhouse gases from being emitted into the atmosphere as we otherwise would. So I think that's a real practical challenge on just the manure side when we think about integrating to some of these other systems that we have to think about, in addition to that effluent storage. If we're trying to get manure out of this pit frequently or close to continuously, we can't use it as a storage anymore and have to make some investment in where we're going to store that. On the feedstock harvest and storage side, we've seen some of this at different places and in different scales before, but maybe not necessarily tied to an anaerobic digestion facility. So in many ways, an anaerobic digester is similar to a cow's stomach, right? It's working under the same general principles, except this is a managed mechanical cow rather than something that does some of the pre-processing for itself. So when we think about a cow's digestion system, they're going to chew that material, help break it into smaller particles. And when we think about taking some of this other feedstock and trying to manage it ourselves, we don't get that benefit. We have to be the processing system to help break some of it down. And that either can occur at the time of harvest, for instance, with chopping and then ensiling, or it could occur later where we make a solid material of bale and then we do some post-processing grinding as we get to using it. And I think both models have been tried. The Europeans have tended to like this silage system for a variety of reasons. And the US systems, especially around here, where we've seen maybe some people thinking about corn stover digestion, have tended to be towards this drier bale system. Ed asked another great question: is the stover to biochar a competing use that could threaten sourcing for anaerobic digestion systems? And I think the answer is both yes and no. When you think about Iowa, we grow about 12 to 13 million acres of corn in any given year. Very little of that corn stover is used currently. The major market for corn stover currently is probably bedding material for livestock and then corn silage material for cattle. But as we look towards the future, yes, I think all the potential conversion methods will compete with each other. And that could be biochar, that could be pyrolysis of the corn stover to help with heating of an ethanol plant, or it could be trying to get that and source that corn stover for biomass material and anaerobic digestion. And they will all compete with each other. And other conversion platforms may be a winner. I think the thing we know about biochar or pyrolysis is that many of our liquid manures, so dairy manure, swine manure, aren't going to be able to be run through that pyrolysis unit very feasibly. They'd probably take some drying before we could do that. And because of that, if we have some facilities where it makes sense, it might also make sense to take that corn stover and end up with it running through an anaerobic digester. On the other hand, if there's not manure resources in that area, a biochar facility might make more sense for corn stover use than just straight anaerobic digesting. I think that's something that remains to be seen and depends on policy. The other part of that we might want to mention or think about is if there are other sources, cover crop being a major one that I think could be a player. And certainly we could think about pyrolysis or biochar production from a cover crop, but given the time constraints in the spring of when we'll want to get that material harvested and out of the way so that we can plant our cash crop that would come later, thinking about the drying time that we might need to get it to something that a pyrolysis plant might want might be more challenging than forage harvest where we can chop it, get it into a bunker silo, and eventually feed it to an anaerobic digester. So I think those are great questions, and I think they're things that we're all trying to work out, but those are definitely things that we have to be thinking about doing. We have another great question on thoughts about adding biochar onto an AD site to run the digestate through after as an add-on technology and an up and running AD site. And certainly I think that's a great possibility and one that I'm interested in trying to see what the costing mechanism works for that. There's a lot of potential opportunities. We know that if we add biochar back to the anaerobic digester, it can help overcome some of the ammonia toxicity. So there's a potentially use for the biochar on site. Adding it into some of maybe that liquid digestate can potentially help hold on to the nitrogen and make it a more stable fertilizer. But if we start adding large amounts of crop residue to the digester, we're still gonna have large amounts of crop residue come out. Hopefully you can still hear me, but it is a possibility. I think the challenges you're going to have is you think about that biomass material for corn stover, for instance. If you're doing well, about half of it can break down in a digester. maybe a little bit more depending on when we're harvesting it. But if we're harvesting after we've harvested grain, I think half of the corn stover being converted into methane and CO2 is a pretty reasonable estimate or a good estimate. So that means half of it's coming out, right? So if we take one dry ton, every dry ton we run through our anaerobic digester, we have at least half a dry ton coming out. The challenge will be that material is going to be pretty wet. Even if you're running it through a solid liquid separator, a good goal to shoot for would be 50% moisture. That's probably on the lower side of what's achievable. I'd guess it'd be more like 60, 65% moisture coming out of that anaerobic digester. And that might be too wet to run through a pyrolysis unit on its own. We might need to do some composting or air drying of that material to make it more pyrolyzable. Or if we have weight heat from either that combined heater power system, or depending on how the biomass system is doing in terms of processing and waste heat generation, there might be some opportunities there. So certainly from closing the loop and talking about circularity, there's some great opportunities. We know that much of the nitrogen is going to end up in the liquid fraction. The phosphorus and some of the potassium will end up in that ash fraction. So densifying them with something like pyrolysis and making a biochar can help us move that material back to the fields that we were harvesting from as harvest radiuses get bigger. So there's definitely some opportunities there. In terms of pre-treatments, there's lots of things that we can do. In practice, not many of them have been used other than grinding. I will say for biological, we've seen some ensiling. Enzymes are something that people are playing around with and seeing some opportunities or options for. Many of them that have been proposed tend to be too expensive to use depending on what credit markets are doing. But I think there's hope there, there's options there, and we definitely saw some interest on the cellulosic side of ethanol production for those. Just a quick summary of digester choices. If you're thinking about just covered manure storages and trying to add biomass material to them, that's probably a very difficult road to work with. If we think about heating and mixing to keep that material suspended and moving through the digester, getting better performance throughout the year, they might be a possibility. But most of the experience with biomass digesting has either been on a completely mixed digester, which you can see here on the bottom right, or with some of these plug flow style digesters where there's just been more experience and the higher temperatures help hydrolyze and break down that material much more rapidly. We're going to skip our gas utilization slide. I have less data on this with materials where we've added biomass in, but we do know that biomass material will make manures resemble more of dairy manure than others before. So other than chopping, maceration, or grinding, are there additional stover pretreatments needed? It depends. There's probably some that you would want to do. You probably want to try and do some ash removal depending on how clean it is coming in. There's certainly some of those hydrolysis, either chemical pretreatments or enzyme pretreatments that people have tried to use in the past. I don't know that they're entirely necessary, but they can make the process faster. One thing that you'll note if you're using dry stover to start with is it does take a little time to rehydrate it and make it so that it doesn't float and separate. So some locations have found sort of a pre-mixing chamber or a hydration chamber to be helpful. That can be overcome with mixing in the digester as well to make sure that that stays mixed in and doesn't separate. So many dairy farms have found some opportunities in the manure separation area, whether that be screens, screw press separators, or all the way up to a decanting centrifuge for either fiber recovery, where we could potentially think about getting it dry enough to do some post-processing like composting or pyrolysis eventually, or thinking about it as a nutrient separation technique. Just some examples of that. So this is a typical dairy manure storage. It got a nice crust on it. If you think about moving to a world where we put a cover over the top of that, that may be hard to deal with or manage when it comes time to get the material out. So if we're adding biomass into our manures and getting something that would probably be more akin to this, which is what's going to happen if we're adding in that cover crop residue or adding in that corn stover residue, some solid separation before we get into that covered storage might be necessary. On the liquid side, I think there's a lot of opportunities, and in some ways, digesters add more options for this, especially if you're doing solid liquid separation. They might think about letting us move more towards different styles of irrigation equipment or in-season nutrient effluent application that we know, at least in the upper Midwest, have the potential to reduce nitrogen losses at the time of application. In terms of solids, stockpiling that material, especially when it's wet, can lead to some challenges. It probably means we have to think towards composting or at least periodic turning to help encourage air drying of that material that's coming out of the digester if we want to be hauling it long distances. And that'll look a lot more like solid manure and something that certainly the world has a lot of experience on. But some of these farms that are more invested in liquid manures and liquid manure technology might not have as much practical experience with, and we'll be asking them to do something different. That composting or air drying can be a good way to remove some of our moisture and make it more amenable to treatment with pyrolysis or gasification systems to hopefully help get some mass reduction as well from that. Just if you look back at the literature, sort of how screw press separators and decanting centrifuges have done, if we're really looking at this as a way to get rid of phosphorus from manure, some of that manure material, screw press separators or screening alone may not be sufficient. We might be having to think about something that does a little bit job of capturing those finer particles. So if that's important for your manure management plan or the scale that you're going to get at, where we're going to need to be transporting phosphorus materials long distances, trying to get to some more of those denser materials or separate that phosphorus out of the liquid effluent can become an important consideration. I've played around with how big of farms need to do this. If you're thinking about this at a 25,000 head swine farm or a 5,000 head dairy cattle farm, you're starting to get to the scale where we might be able to do it, but so much of the nitrogen stays in the liquid fraction that it's hard. On the other hand, if you get to some of those cases where our effluent application is going to be phosphorus limited, things like a decanting centrifuge start to make sense when we get to 12,000 head of swine. So when I say I think it takes about 5 swine farms at 5,000 head each to maybe make a community digester go, if those farms are dealing with some phosphorus limits on where they're putting manure on, doing that separation system on the back end starts to make some sense. The same with dairies, where we've hit that sort of 1,000 head of dairy cattle. And so I think there's a lot of potential to see this type of treatment system post digestion. And that opens up things like the biochar that we've heard discussion about or seen questions about. So I think that took us through the amount of time we wanted to spend today. So I am open for more questions or comments, but a couple of things as we go. If you'd be so willing, we do ask that you'd fill out a voluntary demographic survey if you watch this webinar live. It is voluntary. If you've done it for a previous webinar, you do not have to do it for us again. We have a QR code that should take you to the survey, or you can use this web link. I did want to acknowledge that we're doing this work as part of a USDA Natural Resource Conservation Award. You can see the award number there. The opinions, findings, and conclusions recommendations are based on our information and experience, and they do not reflect what the USDA, Natural Resource Conservation, or others might believe. If you are interested in being part of our 2025 webinar series, we are excited to offer opportunities for partners to talk about some of their experiences, some of the things they're doing to try and make digester projects more feasible. And we especially want to help facilitate connections between farms and digester companies so that they can get to know better who is in this industry and what they're doing. We are going to be taking a couple months off. So January and February, we won't be having a webinar, but we plan to start again in March of 2025. So if you have a topic that you'd be willing and want to present, if you would either go to this web link or scan this QR code, we would be excited to help facilitate you sharing that information. Okay, and Paul says, does most of the feed for swine and dairy farms come from surrounding fields? And to what extent is feed imported, asking for phosphorus accumulation in land application? And it depends. Most of the feed isn't going directly at swine farms. Most of the feed is going to an elevator, getting processed, and then coming back to the farm. But they are often roughly tied to their manure application land base. So we tend to be close to imbalance in most of Iowa, with a few places where there are exceptions for that. And certainly there are exceptions locally at most farms. We do see a higher prevalence of continuous corn around swine farms than on average in Iowa. And swine farms that are running continuous corn rotations will have excess phosphorus in their manure relative to what is being used generally. Those farms that are running corn soybean rotations, which is probably 70% of swine farms, 30% are in that continuous corn rotation, probably don't see much phosphorus accumulation. At dairy farms, there's a mixture of both. again, we'll see more of that corn silage being directly tied to what's being fed to the dairy cows. But given the nutrient content of dairy manure and how we tend to have stored it in Iowa, most dairy manures will have excess phosphorus in them, and it's seen phosphorus buildup. Iowa uses a tool called the Iowa Phosphorus Index, which works in conjunction to Russell 2 to decide when your manure application will be phosphorus limited. But in large part, many of our cattle farms, if it's fields that have a past history of manure, probably are not seeing a fertilizer benefit from applying more phosphorus, but it is case to case dependent. So Iowa manure plans have required in the past that there is some assurances that manure applications are both nitrogen and phosphorus based for crop removals. They're tied to that for nitrogen application. For phosphorus application, there is a loose tie to that with some leniency for what your phosphorus index says is acceptable for building up soil test phosphorus. There's a question on what regulations in Iowa for accepting what. We'll try and get a DNR member to hopefully help answer some of those questions in the future. I do not want to take on that question right now, but I will try and get in touch with you, Paul, after to provide some clarity or lack of clarity on that, especially with digester rules right now. There's some understanding on what those are. I think as we see the industry develop and what people might be willing or want to take, that is a question of how some of these things will emerge. And certainly that is an area of concern. I've seen many in Wisconsin, Minnesota, and some of our surrounding states where maybe digesters have been developing a little bit more rapidly, have those conversations about what does that mean? When is it an agricultural digester? When is it not an agricultural digester? For my part, I think if you're accepting crop residues and adding it to a manure digester, there's some reasonable belief that that will probably still be an agricultural digester and will manage it similarly to how we've managed manure in the past. If you start taking industrial byproducts or biological processing byproducts, I think those conversations get to be more complicated, and it depends answer. But we'll be in touch afterwards. I think, well, you're signed up, so we'll have your email from that. So we'll try and get back to you with your more specific question and what the regulations might be. So with that, thank you everyone for attending. We'll have a press release coming out in March. If you've signed up for one of these webinars in the past, we'll also be sending you an email to notify you when the new season will be starting. But we appreciate the time you've taken today to attend. Hopefully you've gotten at least a few of your questions answered and probably have many, many more digester questions because of it. And over the next year, we'll be trying to address some of those. And thanks, Katrina, for sharing the Minnesota requirements.